All right, it's 6:59, which is about 7 o'clock. So we'll go ahead and get started with our meeting. Thank you so much for coming to. Thank you so much for coming to the ACM General Body Meeting number 5. Please go ahead and log into acm@uc.org/c to register attendance. This is kind of helpful for us to know who's come to the meeting, and just also towards the end when we have elections, you need to be at least in 2 meetings to be able to be a voting member, and so just kind of helps us keep track of that. So please go ahead and sign in at acm@uc.org/c. Before we get started, we're gonna make sure that. Oh wait, what are you guys doing? Are you guys going around? What? Are you guys going around? I was gonna have people grab down.
What did you just tell me to do?
Yeah, can we have first 2 rows come in first and then the last 2 rows? Also for the chips, we only have limited chips, so please, if you can, share it with the person sitting next to you, if you're comfortable, obviously. If you guys want to go ahead and form a line and grab your burrito and chips.
You also have salsa and sour cream up here.
I think someone joined the other meeting. Okay.
Yeah, we're
Okay, see. If two of you also want to go ahead and start forming a line, feel free to.
Thank you. How is it so smooth?
Did that work? Or did that? Oh.
I can do the work, yes. I thought you would help.
No, this is unclear.
Thank you.
Yeah, of course. Good. A little chaotic, but good. Yeah, you.
We're running low, Josh.
Are we? How many people do we have?
Freeze that for a second. I need to open a GitHub repo. It has some code. You can just freeze.
Sorry, I muted because I muted myself because I was talking to Dave about something else before. So sorry about that. But we're gonna go ahead and get started. Thank you so much for coming. Hopefully you filled out the attendance for acm@uc.org/c, and that also applies to people who are joining online. So whoever is online, thanks so much for coming. And we're gonna go ahead, see. A little bit about our mission at ACM. So we basically want to encourage professionalism among tech enthusiasts like yourself in a collaborative fashion, and that means coming to these meetings and working together on projects, or talking on Discord and Slack, and facilitating learning beyond the scope of classroom. So we want you guys to learn things that you normally would not learn in a classroom setting in these meetings, and that's why we have speakers come in and talk about cool ideas. So what is ACM at UC? It stands for Association of Computer Machinery, and it's basically the hub for computer science and programming. Cool kids at UC. It's a group of students built around a common interest in computers, technologies, and software, but you don't have to be a computer science major or an IT major to be a part of it. We do host talks, workshops, hackathons, and other events. I also do see the chat, someone asking for the attendance link. It is acm@uc.org/c. Dave, if you want to type that into the chat, thanks. What do? We host meetings like this, which is one of our events, and we do socials. We also do professional and technical meetings. So we have guest speakers like today. We also do ICPC, which is in March. That is spring semester. Then we also do Revolution UC, which is our hackathon, also in spring semester. Socials, one that we had this past weekend. We also do review sessions for some of the classes. And we also have Slack, Discord, and we also record our meetings. And we have a YouTube channel. Code of conduct, just make sure that you're being nice to everyone. We do have a code of conduct, which you can read at acm@uc.org/conduct. And we also do follow the UC code of conduct. Next thing, Revolution UC. You'll hear me talk about this at every single meeting, but it's a UC student-run hackathon organized by ACM at UC. We are coming back in spring 2022, so do look out for our registrations. It's basically 24 hours of coding, learning, and fun. Usually we have 300 plus attendees, and you get to talk to cool sponsors like Fifth Third, 8451, Kroger, a whole lot of these companies that come to our event. Next, Slack. If you haven't yet, please join our Slack. You can just go at acmcincy.slack.com/signup. And this is usually how we communicate to our members that, hey, today's meeting where we have free Chipotle or free Edge articles or any other events that we have going on. Similarly, join our Discord. It's a little more casual than Slack is, but it's another great way to be more involved into the ACM community. And we usually send out the same information on both the platforms, but I think it's nice to be on both rather than just one. Next, Nishal wants to talk a little bit about Google Developer Student Club.
Hi guys, I'm Nishal. I'm the president of Google Developer Student Club. As you guys already read, we're just a campus community. We're trying to gap the bridge between theory and practice. We're trying to have a lot of technical workshops this semester. If you guys are interested, please just meet me at the end of the workshop or something. But why I'm here today is because of so there are several Google Developer Student Clubs across North American campuses, and we are doing something called the 30 Days of Cloud campaign. We are planning to have 30 workshops, and the campaign is going on right now. And if you want to know more about the campaign, go to cloudcoach.dev. The website is right there on the board. There will be 30 workshops on Google Cloud, and you'll probably have a lot of fun those workshops because they'll be mostly hands-on where you actually get a chance to code as well. That's all.
Hey, Dave, stop bullying our speakers. But thanks for that, Nishal. Do join GDSC, I guess. So next we have our speaker for today, Dave, talking about abstraction in programming. Woohoo!
Thank you. Yeah, sure. Nice to see everyone can make it, and we ran out of burritos so quickly. That was quick. Welcome, everyone. You guys have already heard the spiel about ACM, so let me also give one very quickly about me and ITSA. My name is Dave. I'm a fourth-year IT student here. I'm working as a software developer at the IT Solution Center. I've been working there for over a year now, including 2 co-op semesters and 2 part-time semesters. I also worked as a freelance web developer before that. I'm the president of the IT Student Association. The logo that you see on the top, is it top right? Top right. Yeah.
Today's school was also actually sponsored by ITSA, so for all the monitors, thanks
Yeah, so we also do workshops like these. We have, I think I'm just going to piggyback off of what Josh said. We do workshops on technical knowledge, professionalism, and a lot of that stuff. So let's get into the topic for today, which is abstraction. So what really is abstraction? One helpful definition that I found was this, which is hiding background details or unnecessary implementation. Can I take this off? It's going to be easier to read. Yeah. Right. So abstraction is about hiding background details or unnecessary implementation. It's used as a solution to complexity often. The explanation that I like more, that I tend to use more, is it's the difference between the what and the how. I promise this is going to make more sense later. But let me walk you guys through a scenario. Imagine there is a piece of code or a piece of software, and you come up to me and ask me how it works. Now, if I start explaining you any piece of software in terms of the electrons that are moving around in the computer's chip, or the transistors that make up the microprocessors, or the quantum states of those transistors, it's going to take a really long time for me just to be able to explain what a line of code or what some program is doing. And it will require both me and you to have the knowledge of how these things affect anything inside the computer, or what you see on a screen, or what goes on inside a server like 5,000 miles from here. It's going to be very complicated, like I said, complex. But what we can do is we can hide some of the unnecessary details into something like logic gates. So now we're no longer talking about transistors or electrons. We're talking about logic gates, which will form the building blocks of our understanding of how computers work. And again, we no longer need to talk about electrons and quantum states, but now we're talking about logic gates. It's still going to take a long time, and it's probably not the easiest explanation of what a calculator is doing, right? But we have already abstracted away a lot of details in that layer. We can go a step further. It would probably be the same thing, talking in terms of machine code, like ones and zeros. Now, the computer does understand ones and zeros. That's what's going on, really. But that's not helpful to us in trying to think about a program or to talk about it, to explain it to someone. We can go one step further into something like assembly language. Now we're getting somewhere, because now we see code that we can read, that humans can read, that we can understand, because there's some words and numbers in there instead of just bits and switches. It's still doing machine code. It's still doing electrons and transistors. We just don't care about that unnecessary detail or that implementation detail. We can think in a higher level, because all of those details are hidden behind these layers. But it's probably still going to take a lot of time, and it'll require us the knowledge of assembly language, which I don't. Do any of you guys know assembly? Awesome. Then I'll show you a calculator. I need you to explain it to me in terms of assembly language, and then I'll do this, and let's see what takes longer time. Right. So a step beyond that would be a low-level language like C or C++ or Rust. Yeah, now we don't have to deal with assembly language anymore. We don't have to deal with memory registers. What we now have are variables. We have data structures. We have statically typed variables. We have the most powerful thing, which are conditionals and loops. So now we can talk about programs much more easily. We can make sense of them without having to talk about assembly language or machine code. We can even go one step further to use a high-level programming language like Python. And in doing that, we have once again abstracted away some details like static types, like memory pointers, like garbage collection. And we still have our code, which is probably at this level maybe only two files, or like 200 lines of code maybe for something like calculator. And it's much easier to make sense of. So this is one good example of how abstraction helps us battle complexity, how it helps us think of, talk about, and plan writing code. Any questions so far? Any clarifications? What's up? Definitely, there are a lot other levels which I'm going to talk about soon. Good question. What's up?
For this exercise, is high-level programming interpreted only?
Doesn't have to be. It can be interpreted only. It can be compiled. It doesn't really matter. This is just a kind of thought experiment that I came up with. This is not an exhaustive list. This doesn't have everything. This is just based on my understanding. Does that answer your question? All right. Anything else? All right. So this is not really the only way to think about abstraction. In fact, abstraction is often more useful to us when we create our own abstraction. So for this, let me show you an example here. Let's say that we're building an e-commerce app, because that's the most common example. We have a bunch of products on a screen, and there's a button that the user can use to sort them by price. Now, this function will handle all of that. By the way, does anyone recognize this algorithm? Yeah, I had the same thought. Just on a quick glance, what does it look like? I already told you, it's the function sorts products. There you go. Thank you. It's bubble sort, yeah. Honestly, even I cannot recognize this. I copied this off Stack Overflow. Yeah, it's probably wrong. I don't know. Actually, it wasn't Stack Overflow. It was Copilot. So I think I can be confident that it was right. Copilot is good. So let's say that this is a function that I implement to sort products by price, like it says. So what this function is going to do, it's going to get a list of products, probably from a server, a database, a global state, from wherever. it's going to execute this. Let me use the mouse. I don't know why I'm not using the mouse. It's going to execute this code, which is the bubble sort. It'll sort them using this price key. And at the end, it's going to put the sorted products back in the state where it can reflect on the UI. These details are not really important here. But what I want to focus on is this array here. Now, this function it's living in an e-commerce application. So the code inside this function should really be concerned about e-commerce stuff. But what it's also doing here is sorting an array. So when implementation details like this are combined together, it tends to create complex functions like these. Now let's try to refactor this by creating a new function called sort array, or sort array by key in this case. Now the only job of this new function is to sort an array that it receives as input and return the new sorted array. Now the function that I would have in my project, or the main function that handles sorting of products by price, it's only 2 lines now, because all the implementation detail of how I sort an array in JavaScript is abstracted away in this other function. So that when I'm looking at this function, or when some other developers is looking at this function, they don't have to think about how they're going to sort a JavaScript array. All they have to think about is e-commerce stuff, or more application level, which would be figuring out where the products list is coming from, which for now is just state.products, but maybe it's more complicated than that. And it would be mentioning that the key has to be price here, because we might replicate this function for a lot of different things. We might have sort products by date, by name, by relevance. So I don't want to have a function this big 5 times, where most of the function is really just bubble sort and it's duplicated across it. This also shows us another useful way to think about abstraction, which is we only care about the input and the output. We don't care about how the function does something or how something happens, which in this case is something like sorting array. Another advantage of this is that the implementation detail here, it can be changed at any time as long as the inputs and the outputs are the same. For example, if someone comes up to me and tells me that, hey, there's another algorithm which is much faster or much more efficient at sorting an array than bubble sort. Cool. I can just get the code for that. I can plug it in here, and my application is faster. If it was this function that I was messing with, I'd have to make sure that the products array doesn't get messed with, or like I mentioned earlier, I don't even really understand bubble sort. So there's probably a high chance that I would mess something up if I tried to change this. So when I'm in this function here, the only thing I'm concerned about is how to sort an array. When I'm not in this function, when I'm here or anywhere else in my code, I am not concerned at all about how an array is going to get sorted. I'm concerned about products or e-commerce. Any questions so far? Anyone left behind? Cool. One more advantage of this approach is that this other function doesn't even have to live in my code. I can probably just eliminate it and reach out to some utility library like Lodash, or even standard libraries that come with JavaScript or with any language that you're using. And I can just plug that library sort method. Because again, I don't care about the implementation detail of how array sorting is implemented in any library. I just need to care that it's going to sort an array. By the way, if you're doing anything in JavaScript, I would highly recommend that you use Lodash. It has a bunch of utility methods like this sort by here. They have a huge documentation, and it's really useful. All right. So far we talked about creating abstraction layers and having these kind of abstract functions which help us make sense of our logic, like here, sorting products. Now the question earlier was, are there more abstraction layers? Sure, we can create as many layers as we want, but for this, I'm going to start right where we left off, which is the high-level programming. Now, high-level programming, this will give us things like dynamic variables. It gives us conditionals and a lot of that stuff, which we can use to create algorithms and create applications all day. But when it comes to complexity, there is a reason why object-oriented programming has been the industry standard for a long while. It's because language constructs like objects or classes or functions, they provide a really nice way to abstract away some more implementation details and give us more building blocks that help us make sense of things. Just like how we had electrons or transistors, and then we had logic gates. We can keep going further. We have things like design patterns. What design patterns do is that they are created to solve a very specific technical challenge, and they give us a set of very specific classes that together, or what's the word, in collaboration with each other, they produce a result that we need. I'm going to talk about one of them later today. On top of that, we have other patterns that we get from frameworks. So something like .NET framework has MVC, or the Django framework, Spring Boot, whatever you're using. Most application frameworks will give you patterns like model view controller, which again, a lot of details are abstracted by the framework. So we just have to use their patterns. If you're using the model class, we know that it's going to talk to a database. How it does that, we don't care about that. That's being taken care of. The details of talking to a database, most of them the framework will take care of. Same thing with the controller. A controller is a class that listens to HTTP requests. How it does that, we don't really care about. As long as we declare a class to be a controller, the framework will know that it's going to intercept an HTTP request and provide a response to it. Now, again, on top of this, we have more patterns like architectural patterns like microservices, but I definitely don't want to get into that because that deserves a complete talk of its own. Same with framework patterns. Today, I am going to talk about some object-oriented principles and design patterns and how they can be useful. So let's go back to our example of the e-commerce application. In a second, actually. One of the most useful ways to use classes and objects is for entity classes. So entity is not really a complex technical term. It just refers to a thing. If you're writing software, there's probably 100% possibility that you're writing software to solve a problem in the real world, which means your software or your code needs a way to represent real world things in your code. So one of the easiest ways to do that is using entity classes. Here we have, by the way, do you guys know about UML, Unified Modeling Language? Okay, better question. Who here does not know about UML? All right, a few, cool. I'm just going to give a quick primer then. UML, or Unified Modeling Languages, Unified Modeling Language, not languages. It just gives us a bunch of notation like these boxes here. UML helps us kind of describe mostly object-oriented, but really any kind of programs or software. It helps us make a visual structure, or a visual structure that we can make diagrams out of, that we can collaborate on, things like that. The only UML that we really need to know for here is that this is a class. This is the name of the class. These are different properties or attributes, and these are going to be the methods, or more specifically, the method signatures of that class. So entity classes like these are a really straightforward way to represent an entity in the real world. Like we have a customer here who's someone that can buy a product. A product is something that can be bought, and an order is a representation of a customer buying a product. That's really it. Now, a customer has some behavior. A customer can change his PayPal ID, because why not? And a customer can buy a product. Now, the only input here is the product, and the output is going to be an order. Once again, the implementation here is hidden inside, or actually at this point it's non-existent because it's such a UML diagram. But we don't really need to know what the implementation is going to be, as long as we know that it's going to result in an order, and this function represents a customer buying a product. Same thing with the order here. The order has a method called cancel. Now, all we need to know is that when cancel is called, the order is going to be canceled. That's it. We don't care how it's going to be done. And now we can talk about everything else without being worried about the implementation details. Similar to the sort array method. We only need to concern about canceling an order when we are writing code inside the cancel method. We also have the product method, product class here, which has the change price. Now, if I have some sample I have a sample implementation of this here on GitHub. I'll share the link with you as soon. But basically, it's written in TypeScript, another object-oriented. We have a customer class, which has the same 3 attributes that we saw, and it has a sample implementation of the 2 methods that we have just seen. Again, this is not something that we can run and see an application. This is just very basic bare bones code that probably won't even run, but it's there to serve as an example. We have the 3 classes here. I can share the link later so that you can take a look at that. Questions so far regarding entity classes? Nothing? Cool. Yeah.
I understand this is like a very basic example, but we have any tests where I think that you're complex enough. I feel like object-oriented is one of the most challenging things. Even if people know that they know it, things sometimes don't. So do you have any tips on like how to actually go about planning automated process?
Yeah, definitely. So the first thing is I would definitely recommend starting with entity classes. So just try to recognize what are individual people or things things that have an identity, not just values, but things that might have an identity. Like products usually have a QR code that individually recognize that one product. So that's where you can start. And the next step would be what I have on the next slide. So thanks for the question. Yeah. So again, the classes like these entity classes, they are useful to represent some real world entity. Another thing that's really helpful that developers like to use a lot are service classes. Now, a service is really something that just represents a process, whether that be a technical process like talking to a database, or a business process like in this case, making a payment. So eventually, I'm going to have to add some payment functionality in my e-commerce app. So I can just create a payment service like this. The payment service will have this method that's called send payment request. It'll take in an order, and that's it. I don't have, while I'm planning this out, I don't have to worry about how the payment is going to be sent. I just have to care that there is a method inside the payment service that will do that. Now, when I have to write that code, I can just go inside this method. I can write the code, and then I don't have to worry about anything else. I don't have to worry about where the products list is coming from, where it's being stored, how the user is placing an order. I just have to make sure that the order is placed. I again once have an implementation for this in the shop with services. Let me quickly go to the next slide first. So we can imagine another class like the shop, which can be another entity class. The shop has a place order method, which kind of emulates like one of us walking into a shop, picking up a product from the aisle, and going to the checkout desk. The place order will take inputs the buyer and the product, which is the person who is buying the product. That's pretty much it. And we can imagine that the place order method will call the send payment request at some point once an order has been placed. Questions so far? Is everyone following so far? Cool. It's great to know. So imagine now I built this. I gave it to whoever owns the e-commerce, or if I own the e-commerce, if this is my startup, then I'm very happy. And if someone else owns the e-commerce, and they're very happy. And now they want me to add a new functionality, which would be something like email notifications, let's say. So whenever an order is placed, they also want the buyers to be notified that, hey, you placed an order, because we get that email from literally every e-commerce site. So I can just add another service like this. The service, once again, will have the send email, which will take the order as the input. What? Oh, cool. Why didn't you do that? So the notification service will once again have the send email. It can take in the order, and it'll just send the email. Right now, I don't care how. I can keep on planning my application as long as I want to. And once I start developing it, only then I need to go into send email and write the code for taking an order object, figuring out which email needs to be notified, and then creating the email content and whatever and sending it out to them, which in this case would be SendGrid, I guess, which we can also switch that out. Right now, the notification service is possibly using SendGrid. We can just switch that out, start using Mailgun or Twilio or whatever. Nothing else in my application needs to be concerned with that. All the shop is doing is calling the send email once the order has been placed. That's really it. Another concept that we are kind of, or another pattern that we can kind of see building up here is called an aggregate pattern. Now the shop in this case would become an aggregate. What an aggregate is that it holds a reference to a bunch of other classes or pieces of functionality that are grouped together in a business. So let's say in this case, I can add more services if the e-commerce owner wants me to. If they want me to add an inventory service or talking to an inventory every time an order has been placed, I need to take that product out of the inventory. I can just create another service for that. If they want a shipping service to be notified, something like FedEx, I can just add a shipping service or a delivery service that will take care of notifying the shipping service provider that, hey, this order has been placed, please come and pick it up. And as this goes on, the shop just becomes more of an aggregate because we're just telling the shop to place an order, and it's coordinating all of this logic behind the scenes. It's kind of, how do I put it? I guess aggregation really is the best term for it. It aggregates all of these small services into one. Aggregate pattern is not really that important. We'll get to that at some point, but not today. So far, anything? Any questions? Doubts? Cool. And people virtually just throw something in the chat. We get chat notifications up. So like I said, we can keep on adding more services here, right? And we can just tell add the place order, like in the implementation here. I have the payment service. It has the send payment request. The notification service has a send email method. And here's the shop class. Now the place order, it's pretty simple for now, just creates an order class. It sends the payment request, and it sends the email, or it tells the notification service to send the email. It doesn't send the email. And inside these methods, again, these I've just put this here as placeholder, but in reality, this might look like a bigger, which will probably be using PayPal's API. It'll use some connections, figure out costs, whatever. Same thing here. But we can imagine that if we keep on adding services like these, this method is going to get bigger and bigger. We might have just 2 more lines for, let's say, inventory or shipping. But the more we add here, the more we'll realize that the place order method that should really be concerned about how an order is placed, it now also knows what happens after an order is placed. Like all of these coordination requests, like, hey, payment service, do this, notification service, do this. A good example of this I can think of is that imagine when the food arrived here, or whoever was here, we just announced that, hey, the food is here. Imagine if we had to stand here and point to every single one of you and say, hey, food is here. Hey, food is here. Friend, food is here. Hey, food is here. Hey, food is here. What would that look like? That's really kind of what's happening here. Or that's what will end up happening here if we just keep calling these different service methods from our one place order method. Now, earlier I said whenever we see complexity, or I didn't say that, but it's probably a good saying. Whenever there's complexity, there's probably an abstraction that will solve it, because abstraction is made to battle complexity. So I'm going to introduce a pattern that's called the observer pattern. It's going to get really bumpy now, but let's go back to the food example quickly. The example was that I cannot really stand here and point to every single one of you and say that, please come and get the food. What I can do is like I can just announce that, hey, the food is here. And you just know that you can now come here and get your burrito. That's really what the observer pattern is about. So in the observer pattern, there are these three specific or single purpose classes. These are events, the emitters, and the listeners. Coming back to this example, the event is something that happened in the past, which in this case was the food arriving. The emitter would be anyone who shouts out or who announces the event, and which in this case would be me or Josh. And the listeners would be all of you. Listener would be anyone or any class that's waiting for that event to happen so that it can do something. So we can very quickly start to imagine that the order placed can probably be an event, and these services can be listeners. Now, how that would look like in object-oriented programming, it's kind of represented here. We have an interface. An interface is really just something that tells us what an object is going to be like, which in this case, all the listener interface tells us is that it has an update method. Our services will implement that interface. So instead of send email and send payment request, the methods have been renamed to update. Now we still have our shop. The shop has the place order, but now the place order only calls notify here. It doesn't need to go out and reach out to each of these services. So the method gets really simple. All the method is again concerned about is how to place an order. Now these services here, these services individually subscribe to this order manager. Now subscription, this pattern is also called pub sub or publish subscribe because of these terminologies, publish and subscribe, or emit, listen, whatever. The subscribe is simply going to say that, okay, I'm interested in knowing when an order has been placed. UFP doing its important work. So these services are going to subscribe to the order manager, and the order manager, right, in this example, is just kind of an intermediary class to get some stuff across. It's also going to hold a list of listeners. It doesn't need to know who the listeners are. It just needs to hold the reference to them so that it can notify them. The services have to just subscribe to this. And let me actually pull up the code. It's going to be more helpful. So here we have the interface, which again just says that we have an update method. The payment service has the update, which it's just doing the sending the payment request like the last example. Same thing with the notification service. And the shop here, now you can see the place order, how simple it is. And it's not really going to change much, or at least this part. The place order now no longer needs to know what services need to be notified, or even what events need to be called, or what methods need to be called on that service. In the last example, not only we had to know about the services here, but also what methods to call. Here, we're just going to notify the order manager, and we're done. Now, the order manager here, you can see, is just going to loop over all the listeners and is going to call update, which is something that was provided from the listener interface. And the update, as previously shown, is just going to do whatever they're doing. So patterns like these, we have a set of these classes or concepts, which are the event, the order placed, the emitter, which in this case is the shop, and listeners, which are the services. Am I pointing in the right direction? No, shop is here, service is here. So these are the new building blocks that we can use to think about, or we can use to architect our application. Any questions so far? Is everyone with me? Is anyone even like, if you're even 5% behind, please let me know. I think we have enough time to go like backtrack a little. Nothing? Cool. So patterns like these, observer pattern, they're really helpful in creating applications that have multi-step processes, or it's also called reactive systems, but that's more of a buzzword at this point. It doesn't really get anything across. But if you have complex systems or multi-step where a lot of things need to happen after one, and then even more things need to follow, or especially if you're constantly evolving. For example, now if I need to add the inventory service, I literally don't need to change the code anywhere else. All I need to do, I probably need to add it to the shop, but other than that, all I need to do is to make sure it subscribes to the order manager, and I'm done. Same with the shipping service or any other service that I might need to add in the future. I don't need to unnecessarily complicate my place order. I can just call subscribe on it. So there's multiple levels of abstraction going on here. The first level are the services, obviously, which are abstracting the specific logic of how to send a payment or how to send a notification. The second is this communication here, which says, or more specifically, what happens after an order is placed. Previously, all of the details of what happens after an order is placed was in that method, but now it's abstracted away and it's kind of spread into the services. There's no one place where which has the details of like everything that needs to happen. There's no like, we don't have a document or that. We just have a reactive system that knows what it's doing. The notification service knows that it needs to do something after an order is placed, and that's pretty much it. So I've mentioned so far that abstraction is a really helpful tool in solving complexity problems, right? So does that mean, do we keep climbing up this ladder of abstraction? Do we just keep abstracting everything? The answer to this question is the response that can be made to literally any question in the world. It depends. Sometimes, not always. So I'll repeat it again. Abstraction is a solution to the problem of complexity in your code. So it makes it easier for us to think about the code, to read code, to talk about it, to collaborate. That doesn't mean it's the solution to every problem. Sometimes your goal is not complexity. Sometimes your goal is to be performant. If you're going to be a game developer, you know that the moment your game drops 2 frames, you cannot show your face on social media because you're going to be killed and harassed to death by your game community. So you really need to make everything performant here. Or if you're working on Internet Explorer, imagine if they had the performance as their priority. We wouldn't be bashing them all the time. So if your goal is not to be like the most developer friendly or have the cleanest code out there, if really what you want is to create the fast web browser, to create a fast game without network lag, or to create a fast operating system, or to create a fast video conferencing tool, anything like that, probably abstraction is not going to be helpful all the time. Or if you want proximity to the hardware, if you're working on something like Arduino chips, you don't really have the luxury to abstract all the details. Or if you're working closer to the metal, like something on the kernel or virtualization, operating systems, anything, there's a lot of examples out there. Or IoT devices. What's up?
This can also vary based on what type of abstraction you do. If it's like the one of some compilers, like C will optimize it as much as it can, no matter what abstractions and functions and whatever you do.
Yeah. So the compilers try their hardest to give you the luxury of optimization, but that doesn't really mean you can have like 500 different files just so that you can, I don't know, what do you guys do in C? I'm sorry. But yeah, again, there are some languages, like I've heard that abstraction is free in Rust. I don't know how much that's true, but I want to look into that more. But yeah, compilers definitely try the most, but the more performance you want, you can probably eliminate some abstraction and gain a small bit of performance. That sometimes works. I've created this abstraction ladder, which again has the layers of abstraction that I had across 2 slices, but also kind of like what we're going to do here. Did I think I missed something. So the point here is that we have to find a sweet spot, or each of us have to find our own sweet spot in this ladder. My sweet spot is really in this area. That doesn't mean I don't do programming. In fact, most of my day job is writing code, but my sweet spot is really here. So you can imagine someone like a systems architect. What they really do is they have to architect huge systems in terms of in pieces of software. They're not even like thinking of one software. They're thinking of 5 different pieces of software which can have a database, an API gateway, a cache server, a messaging queue, or a bunch of these different things, and they have to figure out how they fit into each other, how they can produce a combined user experience. And it keeps going down from there. My sweet spot, again, like I said, is here. But if you want to work on more low-level programming, like I said, if you want to work on performance stuff, if you want to build a game, or if you want to build a compiler, or if you want to build a web browser, you'll probably be in this area. Or you can choose to be in electronics. That's not to say that any of these layers is less important or more important. Someone like a systems architect is really depending or is really hoping that the next person knows what they're doing. Similarly, someone like a software architecture who would probably use something like framework patterns or design patterns to create a piece of software or to plan out a piece of software, they or a developer, they kind of hope that this person knows what they're doing so that they can take whatever they plan and write code for that. Someone who's writing code in Python or JavaScript is probably hoping that the compilers, the people who wrote the compilers, know what they're doing. Because like Node.js compiler is written in C++, and I'm not really sure what the JVMs are written in, but most of them would be implemented in low-level language like these. So we're really hoping, or I'm really hoping that they know what they're doing. Similarly, again, these the C++ programmers are hoping that whoever wrote the C++ compilers know what they're doing. And it keeps going on from there. The people who write in assembly, or even in really any language, they hope that the people who are working in electronics know what they're doing so that they don't mess anything up. But this relationship also goes backwards. Someone working on electronics doesn't really need to care about how someone is going to talk or how someone is going to write a function in JavaScript or a function in MATLAB. They only need to care about that it's producing the expected results. Once again, thinking about abstraction in terms of input and output, not the details. Similarly, someone who's writing a JavaScript function, like I was writing a sort array, I don't really need to care about where it's going to be used, what kind of arrays it'll sort. If it's going to be sorting Amazon products or porn videos, I don't really care. All I'm doing is writing a function that sorts an array. So, quick conclusion. Abstraction is the what versus how, or input and output versus implementation. The main purpose is to hide specific details, to battle complexity, to solve complexity issues. If you think your code is getting too complex, there's almost definitely some abstraction that will solve it for you. There's multiple layers of abstraction. Even when thinking about the lowest, like something like a C++ program, we have to remember that there's a lot of layers of abstraction that are hidden behind and what we are operating on. There's a performance cost. Most of the times there's a performance cost. So it's not a solution to every problem. And you have to find your sweet spot in that abstraction ladder that I mentioned earlier. Well, questions so far? That's pretty much it. My socials are here, or yeah, those are my socials. I don't use Instagram. I'm sorry.
Aren't you the dev tag on Slack?
It's on the ACM Slack. So in Slack workspaces, you have your own name basically. Yeah. Also, ITSA, the web we have a website, itsa.ccs.uc.edu. Right now, you cannot access it if you're like outside campus. You can access it on campus Wi-Fi or if you're on VPN. We are working on that. But the website has links for our Teams channel and our campus link page. Make sure you follow that. Thank you for coming.
All right, wait, did anyone have any questions? I don't know if you gave us enough time.
Questions?
Oh, cool. Looks like you did an absolutely amazing job. No one has any questions. Yeah, you covered every single thing. But thank you so much for that amazing talk. I know I learned a whole lot. And yeah, do follow ITSA and join the Teams channel. That's, I think, one of the best ways to stay up to date with what they do. And you guys usually have your meetings on Wednesdays. Yeah, they do have their meetings usually on Wednesdays. Please go attend them. They're super cool, usually like this. What you say? Yeah, they also have free pizza. So you have dinner for Wednesday and Thursday nights. A few updates from us. ACM and ACMW went to Pumpkin Patch this last Sunday. So yeah, here's some pictures from the cool Pumpkin Patch. It was super fun. We'll be doing another social sometime again this semester. We don't know what that is going to be yet, but be on the lookout if you want to have fun time like all the people in this picture do. Join our sibling organization. We talked about ITSA a little bit, but also join UC Women in Tech, ACMW, and IEEE. If you're interested in leading a talk or a workshop like Dave did today, or you just have a cool idea for meeting that you'd like to see but don't necessarily want to do yourself, just feel free to DM me on Slack or just email me at my UC ID. For our upcoming meeting, our next meeting is going to be a mystery meeting. Ooh. So it's going to be a super fun meeting. We promise there won't be any knowledge drop or anything. It's just going to be a nice time for you guys to relax. But the only way to know what we're going to do in that meeting is to come to that meeting. So do show up and we will have free food. And then after that, we'll have a Power BI talk by Amen Consulting. That is a Cincinnati-based consulting firm. So if you're interested in data science or data visualization, that's the talk to go to. Get to know ACM members a lot more, hang out with us on Discord, join voice channels, talk about your experiences or your projects, favorite language, anything that you're working on right now. Lastly, thank you for coming. If you haven't yet, please sign up for attendance at acm@uc.org. And that's it. Thank you so much, you guys. Hope you guys had fun and learned a lot.